Hello friends, the Quasarea channel is here, and today we will embark on an incredible journey through our cosmic home, the Milky Way. Imagine, every clear night, a grandiose spectacle unfolds over our heads. That bright band that crosses the sky is not just a beautiful picture, it is a view from inside our own galaxy. We live inside a huge starry city, and the Milky Way is its shining streets that we see from Earth. Our galaxy is a spiral structure with a diameter of about 100,000 light years. Think about this figure. Light that travels at 300,000 kilometers per second travels from one end of the Milky Way to the other for as long as 100,000 years. And all this time it flies past stars, nebulae, planetary systems. There are between 200 and 400 billion stars in our galaxy. This is more than grains of sand on all the beaches of the Earth. Each of these stars is potentially a whole system with planets, satellites, asteroids. The Sun, our home star, is just one of these billions of stars, and a fairly ordinary, medium-sized one. The Milky Way has the shape of a flat disk with a thickening in the center, which is called a bulge. Spiral arms, twisted clockwise, extend from this central thickening. Our solar system is located in one of these arms, called the Orion Arm, about 26,000 light-years from the galactic center. At the heart of the Milky Way lurks something truly amazing: a supermassive black hole. It is called Sagittarius A and weighs about 4 million times the mass of the Sun. This black hole is a kind of gravitational anchor around which our entire galaxy revolves. Stars near the center move at incredible speeds, completing a full orbit around the black hole in a matter of years. Interestingly, the Milky Way is not static. Our galaxy is constantly in motion. It rotates around its center, with different parts rotating at different speeds. The Sun and our solar system travel around the galactic center at a speed of about 220 kilometers per second, completing a complete rotation in about 230 million years. This period is called the galactic year. Between the stars of the Milky Way stretches the interstellar medium, rarefied gas and dust. This environment is not empty and lifeless. On the contrary, it is from it that new stars are born. In the cold and dense clouds of interstellar gas, under the influence of gravity, stellar embryos begin to form, which eventually turn into full-fledged luminaries. One of the most beautiful star-forming regions in our galaxy is the Orion Nebula, which can be seen even with the naked eye as a nebulous patch in the constellation Orion. Right now, thousands of new stars are being born there, planetary systems are being formed, and perhaps the foundations for future life are being laid. The Milky Way is surrounded by a halo of globular clusters, dense groups of old stars that orbit the galaxy in elongated orbits. These clusters contain some of the oldest stars in the universe and could be as old as 13 billion years. They remember the youth of our galaxy, when it was just forming from primordial clouds of gas. Our galaxy is not alone in space. The Milky Way is part of the so-called local group of galaxies, which includes about 80 galaxies. Our closest major neighbor is the Andromeda galaxy, which is about 2.5 million light-years away. And surprisingly, the Milky Way and Andromeda are approaching at a speed of about 110 kilometers per second. In 4.5 billion years, these two giant galaxies will collide and merge into one even more massive galaxy, which astronomers have already dubbed Milkomeda. Studying the Milky Way is not an easy task because we are inside it. It's like trying to draw a map of the forest while standing between the trees. Dust and gas block the visible light view of the central regions of the galaxy. Therefore, astronomers use infrared radiation, radio waves, and X-rays, which can penetrate interstellar dust and reveal the hidden secrets of the galactic nucleus. The Gaia Space Telescope, launched by the European Space Agency, is creating a three-dimensional map of our galaxy, measuring the positions and motions of billions of stars with incredible precision. Through missions like this, we're learning more about the structure, history, and future of our star home. There are many exotic objects hidden in the Milky Way. There are neutron stars here, incredibly dense remnants of massive stars, where a teaspoon of matter weighs billions of tons. There are pulsars spinning neutron stars that emit directed beams of radio waves like cosmic beacons. There are binary systems where stars dance around each other in a gravitational embrace. There are planetary nebulae, beautiful structures formed when stars like the Sun shed their outer shells at the end of their lives. The Milky Way is constantly growing, swallowing smaller satellite galaxies. Dwarf galaxies caught in the Milky Way's gravitational field are gradually destroyed by tidal forces, and their stars become part of our galaxy. This process of galactic cannibalism has been going on for billions of years and will continue for a long time to come. The history of the study of the Milky Way began long before modern astronomy. Ancient civilizations saw this bright streak in the sky and created myths about its origin. The Greeks called it the Milk Road, hence the modern name. It wasn't until the early 17th century that Galileo Galilei, pointing his telescope at the Milky Way, discovered that this nebulous band was made up of countless individual stars. It took several more centuries to understand the true scale and nature of our galaxy. In the 18th century, William Herschel attempted to map the Milky Way by counting stars in different directions. In the early 20th century, there was debate about whether the Milky Way was the entire universe or just one of many galaxies. The great controversy was resolved in the 1920s when Edwin Hubble proved that the nebulous spirals seen in the sky were galaxies like our own, but at great distances. In our galaxy, there are regions with an increased concentration of stars and gas, where star formation processes are actively underway. These areas are called stellar nurseries. Young, hot stars ionize the surrounding gas, causing it to glow in characteristic reddish tones. This is how emission nebulae, some of the most beautiful objects in the night sky, are formed. Dark matter plays a critical role in the structure and evolution of the Milky Way. Although we can't see it directly, its presence betrays a gravitational influence on visible matter. Dark matter is thought to form a massive halo around our galaxy, and its mass is several times greater than that of all the stars, gas, and dust we can observe. Without dark matter, the Milky Way would simply be blown apart by the centrifugal force of rotation. Life on Earth is inextricably linked to the Milky Way. The heavy elements that make up our planet and our bodies, carbon, oxygen, iron, gold, were all synthesized in the depths of the stars of our galaxy. When massive stars explode as supernovae, they eject these elements into interstellar space, enriching gas clouds, from which new generations of stars and planets then form. We are literally made of the stardust of the Milky Way. The question of whether there is still life in our galaxy remains one of the most exciting in modern science. With the discovery of thousands of exoplanets around other stars, it has become clear that planetary systems are a common occurrence in the Milky Way. Many of these planets are in the so-called habitable zone, where conditions may be suitable for the existence of liquid water and potentially life among billions of stars, planets with oceans, atmospheres. Maybe even intelligent civilizations may be hiding. Projects to search for extraterrestrial intelligence are scanning the skies in the hope of picking up signals from other inhabitants of our galactic home. The structure of the galaxy is constantly changing. Gravitational interactions between stars, clouds of gas, and dark matter create a complex dynamical system. Stars are born, live for billions of years, and then die, returning their matter back to the interstellar medium. This eternal cycle of birth and death has been going on for more than 13 billion years. By observing other spiral galaxies in space, we can imagine what our stellar home looks like from the outside. Majestic spiral arms glowing with young blue stars, dark streaks of interstellar dust, a bright central core. All this we can see in twin galaxies like ours. It's like looking at your reflection in the mirror of time and space. Magnetic fields permeate the entire galaxy, affecting the movement of charged particles and the formation of stars. Cosmic rays, high-energy particles, travel along these magnetic fields, sometimes reaching Earth after long wanderings around the galaxy. Some of them may be millions of years old and travel unimaginable distances before entering our atmosphere. The spiral arms of the galaxy are not static structures, but density waves passing through the disk. Imagine a wave in a stadium. People stand up and sit down, creating the illusion of a moving wave, although they themselves remain in their seats. Similarly, stars and gas pass through spiral arms, temporarily contracting and increasing in density, which stimulates the formation of new stars. The age of our galaxy is estimated to be about 13 billion years, which makes it almost the same age as the universe. During this time, it experienced a turbulent youth, when star formation proceeded at an incredible pace, a period of maturity and gradual calming. By studying the chemical composition of stars of different ages, astronomers can read the history of the galaxy like a book, where each generation of stars is a new chapter. Interestingly, our position in the galaxy is quite fortunate for the existence of life. We are at a safe distance from the center, where the density of stars is high and supernova explosions often occur, which could sterilize planets with their radiation. We're also not too far away on the outskirts, where there aren't enough heavy elements to form rocky planets. This region between the extremes is called the galactic habitable zone. Dozens of dwarf satellite galaxies orbit the galaxy. The most famous of them are the large and small Magellanic Clouds, visible from the southern hemisphere of the Earth to the naked eye as nebulous spots. These galaxies are gradually being torn apart by the tidal forces of our gravity, leaving behind long streams of stars and gas. In the thickness of the galactic disk, there are molecular clouds called dense accumulations of gas, where the temperature can drop to minus 260 degrees Celsius. It is in such clouds that new stars are formed. Gravity compresses the cloud until thermonuclear reactions begin in its center, and a new luminary is born. Our sun has already made about 20 revolutions around the galactic center since its birth. During this time, it crossed spiral arms, passed through regions with different densities of stars and gas, and possibly approached other star systems. Each such journey takes about 230 million years, more than dinosaurs exist on Earth. Modern telescopes allow us to look into the farthest corners of the galaxy. Radio telescopes capture the radiation of neutral hydrogen by mapping the distribution of gas. Infrared observatories penetrate the dust, revealing stars hidden from our eyes. X-ray telescopes detect hot gas and exotic objects such as black holes and neutron stars. The galactic plane is visible from Earth as the same luminous band crossing the sky. If you find yourself far away from the city lights on a dark, moonless night, you will see this stunning sight in all its glory. Billions of stars merge into a milky glow. Dark gaps of interstellar dust create bizarre patterns, and in some places you can see bright spots of nebulae and star clusters. The future of the galaxy will be no less interesting than its past. In billions of years, when the merger with Andromeda occurs, the sky of the Earth will change beyond recognition. If there are still observers on our planet by then, they will see a grandiose spectacle of approaching galaxies, distorted by tidal forces, with bursts of new stars born for the collision of gas clouds. Studying our home galaxy helps us understand the universe as a whole. The processes taking place here are universal and are repeated in billions of other galaxies throughout the cosmos. By observing our starry home, we learn to read the history of the cosmos, predict its future, and understand our place in this grandiose picture. The energy emitted by all the stars in the galaxy is colossal and almost beyond imagination. Every second, trillions of stars convert matter into energy through fusion, maintaining their glow for billions of years. This energy travels through space, and a tiny fraction of it reaches us, allowing astronomers to study distant worlds. There are relatively empty regions between the spiral arms, but even there the stars continue their run around the galactic center. These interarm spaces are less active in terms of star formation. There are fewer young hot stars, but the old yellow and red stars are quietly completing their life cycles. The galactic center hides many secrets. In addition to the supermassive black hole, there is a dense cluster of old stars that form a bulge. These stars move in chaotic orbits, creating a complex dynamical system. Observations show that some stars are hurtling past the black hole at incredibly close distances, experiencing monstrous gravitational forces. Star streams are long strings of stars left over from dwarf galaxies and globular clusters torn apart by tidal forces. These streams wind around the galaxy like cosmic rivers and serve as archaeological sites for ancient collisions and absorptions. By studying them, astronomers reconstruct the history of the growth and evolution of our stellar home. The chemical evolution of the galaxy is a fascinating story of the enrichment of the cosmos with heavy elements. In the beginning, there was only hydrogen and helium left over from the Big Bang. The first generations of stars synthesized heavier elements and, exploding, scattered them in space. With each new generation of stars, the metal content increased until the conditions for the formation of rocky planets and the emergence of life appeared. The rate of star formation in a galaxy is now about 1 to 2 solar masses per year. This means that the equivalent of 1 or 2 suns appear each year in the form of new stars. This may seem like a lot, but compared to the galaxy's youth, when the speed was tens of times faster, the modern pace is quite calm. The galaxy is maturing and calming down. Gravitational lenses allow us to see distant objects outside our star system. When light from a distant galaxy passes by a massive cluster of stars or dark matter, its path is curved, creating an enlarged or distorted image. Sometimes astronomers use the stars of our galaxy as natural telescopes to study even more distant corners of the universe. Pulsations and vibrations pass through the galactic disk. Gravitational interactions with passing dwarf galaxies create waves that cause the disk to bend and oscillate. These movements are very slow by human standards, but over millions of years, they significantly change the shape of the galaxy. Cosmic dust, which complicates observations, is an interesting object of study in itself. These microscopic particles are made up of silicates, carbon, and ices. In cold molecular clouds on the surface of dust grains, chemical reactions take place that synthesize complex organic molecules. Some of these molecules may be precursors to life, making interstellar dust a potential cradle of biology. There are two types of star clusters: open clusters and globular clusters. Open clusters are young, contain from several tens to thousands of stars, and are located in the galactic disk. The famous Pleiades are a perfect example of such a cluster. Globular clusters are ancient, compact, contain hundreds of thousands of stars, and orbit the galaxy in elongated orbits, forming halos. The metallicity of stars is a key parameter for understanding their age and origin. Astronomers call all elements heavier than helium metals. Stars with low metallicity were born a long time ago, when the universe was young and poor in heavy elements. Stars with high metallicity, like the Sun, are younger and formed from material already enriched by the explosions of previous generations of stars. Radio emission permeates the galaxy. Clouds of ionized hydrogen, supernova remnants, pulsars, active nuclei, all of them radiate in the radio range. Radio astronomy has opened up a completely new view of the cosmos, invisible in optical telescopes, and continues to make amazing discoveries. Galactic archaeology is a new direction in astronomy that studies the ancient history of our stellar home. By analyzing the chemical composition, motion, and location of old stars, scientists reconstruct events that took place billions of years ago. Mergers with other galaxies, stellar migrations, and epochs of intense star formation. Variable stars change in brightness over time. Some pulsate regularly, expanding and contracting, while others are eclipsed by their companions in binary systems. Cepheids, a special class of pulsating stars, serve as cosmic measuring bars, allowing astronomers to determine distances to distant objects. It was with their help that Hubble proved that other galaxies are far beyond our own. The stellar wind blows matter from the stars back into interstellar space. This process is especially intense in massive and old stars. Red giants and supergiants lose a significant portion of their mass through powerful stellar winds, enriching the surrounding cosmos with heavy elements even before they explode as supernovae. Gravitational waves from merging black holes and neutron stars can now be detected by detectors on Earth. These ripples of space-time spread throughout the galaxy, carrying information about catastrophic cosmic events. The discovery of gravitational waves has given astronomers a whole new way to study the universe. Avoidance zones are areas of the sky where observations are hindered by a dense concentration of stars and dust from the galactic disk. Behind this veil are entire galaxies and clusters of galaxies that are difficult to observe because we're looking through the densest part of our stellar home. But even these hidden areas are gradually being revealed thanks to infrared and radio telescopes. Hypervelocity stars are true cosmic escapees, moving at speeds sufficient to leave the galaxy forever. Some of them were ejected by the gravitational slingshot of the central black hole. Others were accelerated by supernova explosions in binary systems. These stars travel through intergalactic space, taking with them a piece of the history of their home. The thick and thin disks are two distinct populations of stars with different characteristics. The thin disk contains young metal-rich stars orbiting in circular orbits close to the galactic plane. The thick disk is made up of older, metal-poor stars moving in elongated orbits and farther out from the plane. This is evidence of the complex history of the formation and evolution of the galaxy. Galactic fountains are a phenomenon in which hot gas heated by supernova explosions and stellar winds is ejected from the disk to high altitudes, then cools and falls back. This circulation of matter plays an important role in regulating star formation and mixing chemical elements throughout the galaxy. Population stars 1, 2, and 3 represent different generations of luminaries. Population 3, hypothetical first stars of the universe, consisting only of hydrogen and helium. They were massive, bright, and short-lived. Population 2 are old stars with low metallicity, formed from material slightly enriched by the first generation. Population 1, modern stars similar to the Sun, rich in heavy elements. Tidal tails are stretched away from dwarf galaxies being torn apart by the gravity of our stellar home. These streams of stars can stretch for hundreds of thousands of light years, creating ghostly bridges between galaxies. By studying these structures, astronomers understand how galactic cannibalism occurs and how galaxies grow by devouring their smaller neighbors. Ultra-compact dwarf galaxies are strange objects that may be the cores of larger galaxies stripped of their outer regions by tidal forces. These dense star systems, which are the size of a globular cluster but contain the mass of a small galaxy, pose interesting puzzles to astronomers about the evolution of galaxies and their interactions. Cosmic strings and dark matter filaments, if they exist, can permeate the galaxy, influencing the distribution of ordinary matter and the formation of structures. Although dark matter remains mysterious, its presence is felt everywhere through the gravitational effect on visible matter. Magnetars are neutron stars with incredibly strong magnetic fields, trillions of times greater than the Earth's magnetic field. During flares, these objects release a colossal amount of energy in a matter of seconds. About 36 magnetars are known in our galaxy, and each of them is an extreme laboratory for studying physics in conditions unattainable on Earth. Stellar nurseries in giant molecular clouds are factories for the production of new suns. Clouds can contain a mass of millions of suns and extend for hundreds of light years. Inside them, turbulence, magnetic fields, and gravity create dense knots that collapse into protostars. The process of star formation is complex and not fully understood, but observations are becoming more detailed. Brown dwarfs are failed stars, objects intermediate between planets and real stars. Their mass is not enough for sustained thermonuclear fusion of hydrogen, but they are too massive to be planets. There may be as many of them in the galaxy as ordinary stars, but due to their faintness, they're difficult to detect. They represent a special population of substellar objects. Galactic tides from nearby galaxies leave imprints on the structure of our stellar home. The large and small Magellanic Clouds are not only satellites, but also actively interact with the disk, causing distortions and stimulating star formation in some areas. The Magellanic Stream, a huge jet of gas extending from these galaxies, is evidence of this interaction. Neutrino fluxes from the Sun and other stars permeate the galaxy. These elusive particles have little to no interaction with matter and pass freely through planets and stars. Neutrino astronomy opens a unique window into the processes that occur in the cores of stars and in supernova explosions, providing information that is not available by other means. The kinematics of stars, the study of their motions, reveals the dynamic structure of the galaxy. Stars don't just rotate around the center in circular orbits. They also oscillate up and down relative to the plane of the disk and radially move in and out. These epicyclic movements create a complex picture of stellar trajectories. Accretion disks around the black holes at the center of the galaxy and around neutron stars are extreme environments where matter is heated to millions of degrees and emits X-rays. The study of this radiation allows us to understand the physics of accretion, jets, and other processes near compact objects. Star pairs in multiple systems are extremely common. More than half of the stars do not exist alone, but have companions. These systems evolve together, and interactions between stars can lead to exciting phenomena. The flow of matter, common shells, mergers that give rise to unusual objects. Planetary systems around other stars show amazing diversity. Hot Jupiters orbiting closer than Mercury, super-Earths, ice giants, systems with multiple stars. The architecture of exoplanetary systems is often radically different from our solar system. This indicates a variety of ways in which planetary systems are formed. The circumstellar disks around young stars are where planets are born. High-resolution observations show rings, gaps, and spiral structures in these disks, likely caused by forming planets. We are witnessing the creation of new worlds in real time, which helps to understand the origin of our own solar system. Stellar winds from massive stars create bubbles of hot, rarefied gas in the interstellar medium. These bubbles expand for tens of light years, sweeping away the surrounding material and creating shells of dense gas where a new cycle of star formation can begin. This is how massive stars affect their surroundings even during their lifetime, before the explosion of a supernova. Immerse yourself in a thrilling journey through our cosmic home, the Milky Way. In this video, we explore the majestic spiral galaxy that houses our solar system. Learn about the hundreds of billions of stars that make up the galaxy, the supermassive black hole at its center, the spiral arms where new stars are born, and the dark matter that holds this entire grand structure together. We will talk about the motion of the galaxy in space, how it absorbs dwarf satellite galaxies, and about the upcoming collision with Andromeda. You will learn about the different types of stars, nebulae, neutron stars, pulsars, and other exotic objects that inhabit our star city. We will discuss star formation, the chemical evolution of the galaxy, and the possibility of other life forms among billions of planetary systems. This is a complete overview of the structure, history, and future of the Milky Way, from its formation 13 billion years ago to the distant future when it merges with a neighboring galaxy. Join the Quasarea channel on this epic space journey.